Hey there, in this video I want to talk about solving simultaneous equations. The nice thing about the relaxation method that we learned earlier is that it works with multiple equations just as well as it works with one equation. Would be like if we have an equation that we could write in the form x equals f of x and y, and simultaneously we have another equation that we could rewrite in the form y equals g of x and y. Oh, that needs to be marked down cell. So we're trying to solve these two equations at the same time. And the trick here is we write our relaxation method as before, where we update x and y at each step. But the important thing is that we have to update x and y at the same time. This will break if you update x and then update y. You have to instead update them at the same time because both x and y have to be using whatever values you had in the previous steps. Not like half a step, but in the previous steps. And then you check your convergence, checking both x and y to make sure that they're both within your tolerances, and then you can say, okay, I found a solution. For demonstrating how this works, let's redraw or reprint the output after each step. So I'm going to use a display from IPython, and I'm going to use time to build in a little bit of time delay so we can just watch how x and y converge. So from IPython, I'm going to import display, and I'm going to import time. All right, so let's make up some functions for f and for g. I'm just going to make up some stuff. I mean, hopefully this has a solution. Let's go with like some kind of square root of 2 minus y on y. I mean, I guess we could put some x's in here too. How about we go like x plus 2 minus y on y. And then for g, go with x divided by 1 plus y squared. So I mean, I just made these up. I don't know what the solutions are, if they have solutions. Let's go with an initial guess of just 1, 1 for, well, it seems like an okay number, and we'll see if that works. And let's do 50 of these steps. More generally, you do a very large number of steps, checking for convergence with an if statement breaking like we did in the previous video, but here I just want to show what happens during 50 steps. So now here's the magic line. We need to update x and y at the same time. So we're going to use multiple assignment here, tuple unpacking with x and y, so that x gets set to f of x and y, and at the same time y gets set to g of x and y. And this guarantees that we're using the previous values of x and y before updating them. We don't want to update one and then the other. That's not exactly the right method. You might get solutions, but you're not really following the relaxation method if you do that. And now what we're going to do is we're just going to show our results. So I'm going to use display to clear the output. Set weight here equal to true, and then we can print. I'll do a formatted string, something like x equals x and y equals y, and maybe like a counter for the iteration here. So we'll do like iteration I guess really it's I plus 1, isn't it? So that, you know, because it's already updated by the time it prints, so it's I plus 1. And okay, this would run really fast, so we're going to do a time.sleep. And we'll sleep for 1/10 of a second. All right, let's just see what happens. Okay, so this code is iterating on those values. And you can see x is converged before y. Y isn't quite converged yet. So we might want to do more values in here just to see if it converges. Or I may have picked equations that don't really have a good solution. Yeah, what we have here, okay, y is converging. It's just taking it a while. You can see how we're like locking in decimal places. And so we've converged to 1.618, and y looked like it was good out to like 3 decimal places or so. With more iterations, though, we could converge, and typically what you would do is you'd build in an if statement checking both x and y to make sure that they are within some tolerance. But other than that, it's just the good old relaxation method that we saw before, just with more equations at the same time. You're probably wondering, can SciPy do simultaneous equations for me? And the answer is yes. It's a little bit tricky to write though. So if we look at fixed point, that's the function we used to do relaxation method with single variable. If we look at its options here, we've got func and x naught, and func is the function to evaluate. X naught is array-like, and that's right there a hint to us that we can pass in both x and y here at the same time. Now the thing is, at the moment I have two functions, and for this to work I have to have a single function that takes an array as an argument and then returns an array of values. So I have to rewrite my functions in a different way. So func here takes a single array, I'll just call it xy because it contains both x and y, and its job is return our old functions. So it can return f of xy, g of xy. Now just writing it in this form won't quite work because this is a tuple and it needs to return an array for this fixed point function to work. So we have to specifically turn this into an array like so. And then the other issue here is we're passing in an array xy, but these functions want separate x's and y's. So we have to take xy apart. We can do that with tuple unpacking. So xy equals the array xy. That's our new function. And then in here, we can call func, and we want to give it an array of values here. So this x naught needs to be an array of values. So we'll do an array of, our initial guess was 1, 1. And now if we run this, we get our solution. So like 1.61, 0.896, 0.86. So yeah, you can do it using SciPy, but it's harder to write the function. And this isn't the only place where SciPy does things like this, where you have basically multi-dimensional functions that take an array and give you an array at the end. So it's worth learning how to do it. On the other hand, for this particular kind of problem, it might just be easier just to code it out by hand because the relaxation method is a pretty simple method.